Let's take another shot at how to anti-differentiate. This time I'm going to use fractions a whole bunch of times. So let's say we've got f dash x or f prime x is equal to, and let's say it's 2/3 x squared minus 1/5 x plus 2. And we want to anti-differentiate that. So what we've got, notice we've got fractions here. In fact, I'm going to make that. No, I'm going to leave it on. No. Let's make it 2/3. That'll do. Now, the reason I'm putting fractions on the bottom is people often get confused by the fractions and what they mean when we come to divide by the new power. So let's rewrite this now. So f of x, if that was x, then f of x would be equal to, and I put 2/3, and I'll make Novincium a little bit longer there, 2/3, and you can put the x along the side here, or you can put the x on the top. It makes no difference because it really is on the top. Okay, so 2/3 minus, I've got 1/5, I'll make a slightly long Novincium there, 5th, and there's going to put the x there, plus, and this is just 2/3. All right, so I'm going to increase the x power by 1. It's a 2 there, it's becoming a 2, 3 here. And I'm going to divide by the new power. So that 3 now goes on the bottom. There it is. So when I divide, really what I'm doing is I'm multiplying by that denominator. So I keep the 3 I've already got and multiply by that new 3 again. So this now was an x to the 1. Here it is, x to the 1 is now becoming an x to the 2. And we're going to divide by that new power. There it is. Now this is going to become an x to the 1. And we're going to, of course, divide by that new power. There it is on the bottom. And we're going to add our constant of integration. So let's tidy this up. So f of x is equal to, this is going to be 2x cubed on 9 minus, well, this is 5 times 2 is 10. Now, you could have 1/10 x squared if you like. I actually don't really like that. This is 2x on 3 plus c. So really another way of saying this here is 2/9 x cubed. But I just prefer 2x cubed on 9. Same deal, because the x actually is on the top line. Minus, here we go, and this is, I got 1/10. So you could have 1/10 x squared if you want, but I'm actually, because the x is on the top line, I'm going to go minus x squared on 10, and we get rid of one component. In other words, it becomes more succinct. And we're going to add to the end here. You could say 2/3 x if you wanted, but I'm just going to have plus 2x on 3. Doesn't change the actual number of components like it did with the 1, because we don't really want a coefficient of 1. It's kind of weird, because 1 times something is itself. It doesn't really add or subtract from the actual, doesn't detract from the actual, the way it's written, other than to add a component that we don't really need. So I would prefer to write it like that, but really it doesn't matter how you express your f of x, yeah? So you could do it either way, and that would be fine. You choose. The important thing to realize is, though, when you divide by the new power, if there's already a number on the denominator, you just simply combine them together, just simply by, in each case, multiplying by the existing denominator. And you end up with a new denominator as such. Hope that makes sense, folks.